So in week 6 has asked us to implement the related functions about the heap data structure. The heap data structure has many functions, and these functions, most of the functions has provided us in the blue one above here, and he asked us to implement the related functions here. And first we look at the first function, bottom heap. The bottom heap is when we want some nodes to down the node, to down another node, to make the tree be the absolutely tree because of some insert operation, some delete operation. Maybe all need the bottom heap. So we need to install the position and should be at 1 first. And my idea is using while to loop all the layer for the tree, and this is the adjust. And if it has only left node, or both node has, and if there is no node here, so this is we just have left node. So we have left node, we just do this swap is enough. And this is the compiler. The compiler is the justify we need to, whether we need to bottom heap it. And then here is the key function, the key code. The key code will compare the right and the left. If the right is bigger, and it will swap with the further node, and if the right is bigger, it will swap with the further node either. And if the right one is bigger, the should add 1 is true here, and the index should add 1 here, because the right node is the further node's index middle 2 plus 1, so we need to add 1. And this is the bottom heap. And the swap here, I defined a special swap. It is overload. It is overload with this one. We have different parameter here, so we just swap the two elements from these two elements in this data set instead of this, because this is swap two elements in the heap. So this is swap two elements just in this data. And we move to the next function. The next function is delete. Delete is delete a node, a special node, and make the tree to be absolutely binary trees either. So first we adjust it if it is empty. So if it is empty, we throw an arrow here and swap the first one to the last one, because this is just delete the header node, and we swap it to the last and remove the last, so that we delete the header, but the last is now header, so it is not stable. So we need to try to bottom heap either here and to make the tree to be a absolutely binary tree, and it is the same as the top function, the same idea of the top function. And final, return the node. The node is data count, and this is what we delete. Return the delete node here. And here is build heap. Build heap is we have all keys and all data, so we use bottom to up way to build a we build a binary tree, absolutely binary tree. So the idea is here we first adjust whether it is empty. So if it is not empty, so this tree has something here, so we can't use this, so we throw an error, invalid operation error. And the ordinal nodes is to store the ordinal order of each node instead of is sorry, not instead of, to store the ordinal node's order and its position, and use for loop to give the value for ordinal nodes. And the nodes store the home tree. It is the true data, and this is just the ordinal order, and the ordinal order will change their position, and we will return the changed position in the final here. And this is the true trees data, and we create the first as the default one because it is the header, and the position is the minimize of the key length and the data length, and the level is the trace level. So we use this to adjust whether we need to check the next layer. So this is the nodes number. The nodes number is how many number we haven't add into the nodes. So we use the while loop, and while loop will form the home tree here. And first we need to declare how many nodes we need to add in this loop, and level plus 1 because this is the new layer, so the ID we need to plus 1, and the position we need to we need to do this. So come to the for loop. The for loop is add the node here and use the bottom heap if the level is bigger than 1, because we need to check and form a tree here. And each for loop we need to -1 for nodes number. And final, we need to collection the nodes, and we need to give the data to this point data and give the length to the count. And this is for change the position. This is change the position and return the original nodes. And decrease key is to give a new key to the this is the node. Give a new key to the node's key, and then rebuild the tree. So we just have a short loop for this. This is the same as the top, just change one node here. So and this function will use the up heap and rebuild it. And final, we check the result. The result is success, and the result is good here.